Okay, so I'm recording this video to show my professor later on today. I want to give a walkthrough of this PCI 3-node system that I have built, and I'm using hardware from Dolphin Interconnect Solutions, a Norwegian company, and I'm using some of my own hardware. That computer back there, the white computer, is mine, and the HP OmniDesk computers. There are two of those. Excuse my messy desk. I'm not good at cable management. So I've got one, that white computer there is a ASRock motherboard with a 1660 Ti graphics card that I'm not really using for this project, but each of the three computers, there's another OmniDesk there. Each of the three computers has a Dolphin MXH930 PCI card installed inside of it. That was a hassle in itself getting that set up. But once I was able to get the computer to where it could read that and still load the operating system, I did run into an issue with Windows where basically the bus location where the memory was supposed to be stored for the PCI card was overwriting where the Windows, one of the boot operations of the Windows was being blocked by that remapping, and instead of going by its own mapping system like Linux will do, it tried to use the mapping system that was loaded in the OS, the Windows operating system, and it just would not work no matter what I did. I reached out to Dolphin about it, but I ended up switching to Linux. So each one of these computers is dual booted with Windows and Linux Mint, but I'm only using Linux Mint for the project. So each computer has Linux Mint installed. Some of the hardware here, you can see these fat cables with the green tag on them. There are two running out of Ghost, which is this white computer here, and one connecting from Ghost to Dolphin Binny 1, and then another connecting to Dolphin Binny 2, which are my three nodes. So let's get it started so that I can show some of the software. To run it on the remote node, well, basically they all have to have the same code base loaded, which is an extensive number of files. This has my performance evaluation stuff on it, but it won't whenever I'm done, and it has some markdown files that I've been using. But most of it is here in the demos. These are all the C programs that are running to make the program work, and then also in Java. It's hard to look through the phone here. Let me see. Oh yeah, the source Java files run the source Java files run the GUI interface that I'm about to show right now. So once all computers, all three nodes have that file system on them, then we would run the remote node shell to get that to start reporting information. You can see that it starts to report information there. And we're going to run the same command on the second node. Okay, that's starting to report information. Now we go to our main node, and this is Ghost, which is the primary node, the white computer that has both leaf nodes connected to it. So we're going to run that, and you'll see that it pops up a GUI. It's building right now with Maven, and then it pulls up this interface. This interface is a Java program that I wrote. I wrote all of the C programs and all of the Java programs. What this does is it has all three nodes. So that's the Ghost node. It shows the CPU usage at in between 15 and 30%, and that kind of bounces around. But that's the one that's running the GUI, so it has the most computer usage. And Dolphin Binny 2, you can see this is node 2, has almost no computer usage, and the CPU usage, and Dolphin Binny 1 is the same. It shows the memory drives. The storage here is about 31.5% of the files that I have on the computer are filling up 1.61 gigabytes of the total memory available to that system. And Node 2 also has very low memory because these computers are brand new. Basically, I've only installed this software on it. And then the latency and bandwidth numbers that are there, those are accurate and they're reporting live from the other nodes. And they kind of vary a little bit, but they have been averaging at about 23 gigabytes per second, which is insanely huge throughput. It's like 3 laptops per second worth of data it's capable of transferring, with a latency of about in between 2 and 3 microseconds. So it's just super duper fast. The network bandwidth and latency are both shown live there with graphs that kind of show how the two different remote nodes are performing. Over here, I've got a list of 5 demos. The first one is a file transfer. I need to fix this later, but it shows 1 gigabyte in less than 1.25 milliseconds. But the way that I actually programmed it is with a smaller file. So whenever I hit that, it pops up with the performance, and it took 25 milliseconds. I think that should be microseconds. That should definitely be microseconds to transfer 64 megabytes, which is at a speed of 21.269 gigabytes per second, and did that many megabytes per second. So that's just a conversion there, 1,000 megabytes in a gigabyte. So that is the file transfer demo. The remote memory, it will show max latency and minimum latency for 1,000 iterations. Basically, that's doing CRUD operations. It writes 1,000 times to a remote destination and then reads that 1,000 and brings it back to show the total time and the average latency. That's what that one does. The transparency test does 100 operations. This one basically goes to a random assortment of nodes. So some of the calls are to itself, some of the calls are to the other nodes, and the application does not realize that it's writing or reading from other nodes. It just assumes that it's local memory, and so it has direct memory access speeds, which is an average operation time of 2.63 microseconds, which is crazy fast. That's the type of speed that you would see on local memory, but not on a remote node. For the neighborhood scale, these PCI cables don't actually work for geographical scaling. The problem is that after you reach about 5 meters or so with these cables, they lose a lot of reliability. And so basically, whenever I scaled this geographically, I would have to use fiber optic instead of the PCI cables. But there is a PCI to fiber optic cable that already exists and is being manufactured by a company that works with Dolphin ICS already, and I forget the name of it just now, but I'll find out if you need me to tell you that. So that's the transparency demo. Basically, it just accesses memory from random locations and shows that the computer does not know the difference. The interrupt demo, this does 100 rounds to find out the round trip time. Basically what that does is it sends a message to the remote node and then has that remote node send a message back. And the reason for that is to show the round trip time, but also to show that the receiving computer, the computer that receives the initial message, is responding immediately due to this interrupt that is available in the SISCI SISCI API software that I'm using from Dolphin. And yeah, so that measures round trip time, which is insanely fast at 26 microseconds to send a message back and forth. When that scales up to fiber optic, it is a little bit slower. You lose a little bit, but it's not nearly as much as you would think, and it's still much faster than other fiber optic solutions, because it uses computer to computer communication in a way that goes around certain communication protocols that exist in traditional systems. So that's the interrupt demo. This fabric drive is actually pretty neat. It creates a memory pool of the 3 different nodes, and this is kind of what makes the virtualized data centers a possibility, because you need memory pools that are accessible by machines outside of this 3-node fabric system. So whenever I press that, you'll see that each of the nodes has a storage amount there. That's 20.3% storage amount there. On the primary node Ghost, I've got 1 storage here, but whenever I press the button, you'll see a second storage appear there. That's temporary Dolphin. I have it right now where it automatically unmounts itself in 90 seconds, just so that I can show it as the demo. The reason that I have it that way is just for the performance of my metrics up here in the demo. Whenever that runs, they tend to get a little bit sporadic, and so I had that to where it's unmounting after 90 seconds instead of just staying constantly available. So whenever that unmounts, then the extra storage container disappears, but that could remain constant, and it could be accessed by systems outside of this 3-node system, which makes the virtualized data center possible. These reporting agents on the 2 remote nodes can run in the background, and they don't require much CPU usage at all, as you can see. To show that these are live numbers, if I start moving the mouse around on one of the nodes, you can see that the computer usage starts going up. That's just to show that it's it's live. It's not reporting fake CPU usage or anything like that. Every number in here is actually reporting live. It's not hard-coded or pre-programmed or anything like that. So that is the complete demo that I intend to show at the Innovation Day, and also this is the demo that I'll be using to do all of the performance metrics, which I've got a performance analysis report that I'm also turning in, and it's what I'll be using to test different security things for the security analysis, and basically I'll be using this system for all of the reporting for the rest of our directed research course. I hope you like it.